In our world, if we take something and then we add something to it, we can comfortably claim that the result is bigger than what we started with. Now, what if I told you that there is an entity that does not follow this law? That is, if we take it and then we add something to it, we cannot claim that the result is bigger than what we started with. This is the realm of infinity. In this video, we will study the mathematical concept of infinity. Specifically, we will try and answer the question, is there anything that is bigger than infinity? In order to do so, we will learn some of the language and rules of mathematics. Doing so will allow us to reason precisely and carefully about this beast that is infinity, and in the process we will arrive at some counterintuitive ideas. In order to answer the question, is there anything bigger than infinity, we have to mathematically and precisely define what it means for one set of objects to be bigger than another set of objects. In our daily lives, given two different sets of objects, in order to compare their size, we either use our visual intuition or we count. But over here, we are looking for a general definition or a procedure that will allow us to conclude precisely and convincingly that one set is bigger than another set. Let's say we're given two sets of objects and we want to compare their size. We design our definition as follows. We say that the two sets have the same size if we can perfectly match up their objects. In this case, we have a set A and a set B. And over here we can conclude that set A has the same size as set B because we can create a perfect match between the objects of the set and there are no leftovers. Now suppose I add two elements to set B. I'm adding two extra elements to the set B. Now we cannot anymore claim that set A and set B have the same size. This is because we cannot create a perfect matchup between the elements of the set anymore. Because these two new elements in set B have no counterparts in set A to be matched to. So in the case that there is a leftover pile as such, we extend our definition to say that in the case that there cannot be a perfect matchup, the set with the leftover pile is the bigger set. Now let's build our conception of infinity. I want us to think of infinity as a bottomless bag with an infinite number of elements. So this bag has an infinite number of elements inside it, but it also has the special property that no matter how many elements you take out from the bag, there will still be an infinite number of elements that remain in the bag. Now I know this sounds crazy, but I don't make the rules. Now we are finally ready to answer the question, is there something bigger than infinity? Because we know now in a mathematical sense what it means for something to be bigger than something else and what infinity is. So surely the first and most obvious candidate is infinity plus 1. Surely infinity plus 1 is bigger than infinity. Let's check. In order to check whether infinity plus 1 is bigger than infinity, we have to compare the size of these two sets. Down here, I have drawn a visual representation of the set infinity. So this is an infinite set. This set has an infinite number of elements and these dots indicate that the elements go on forever. This is like our bag that never ends. And this is another infinite set plus 1. So this is infinity plus 1 and this is infinity. Now in order to compare the size of these two sets, we have to refer back to our definition. That is, we have to check if we can find a perfect match between the elements of these two sets, or if we have any leftovers. So let's do that. So visually it does seem like infinity plus 1 is bigger than infinity, because if we start matching the elements of the two sets as such in the most obvious way, we can see that there is an extra element left which has no match. However, consider another arrangement. where this element goes here, this goes here, this goes here, this goes here, and where does this go? This goes to the next dot. And we can do that because the elements in this infinite set go on forever. Similarly, the next dot will simply go on to the next dot. And in this way, we are able to form a perfect match between the sets infinity plus 1 and infinity. So in fact, infinity plus 1 is equal to infinity. We've just proved that, and that's quite crazy. Now let's consider a more compelling candidate. Surely infinity plus infinity must be greater than infinity. This makes sense intuitively, but let's check it against our definition. So what we're doing is we're comparing the size of the sets infinity plus infinity with the set infinity. And I'm not going to say much here, but I'm going to create a match visually and you guys can track it. So this goes here. Now if you take a second to pause the video and see the match I have created between the two sets, you will be convinced that infinity plus infinity is actually equal to infinity, because according to our definition we have been able to create a perfect match between the two sets. So this candidate too has failed. Now in our desperate attempt to ensure that there must be something bigger than the set infinity, we test our final and most viable candidate, infinity times infinity. Surely this must be bigger than the set infinity. Let's check it. Over here I've drawn a visual representation of the set infinity times infinity using some of the principles we learned in my second video. Now let's check. In fact, I'm not going to do much, but what I will do now will surprise you. I am going to create a perfect match between the sets infinity times infinity and the set infinity. You can track what I'm doing here. 2, 3, 4, 5, 6. You can see that what I've done here is that I've embedded the set infinity within the set infinity times infinity. And this is a very interesting visual and beautiful way to show that infinity times infinity is again equal to the set infinity. So, is there something bigger than infinity? We're going to find out, in fact, in my next video. So in this video we proved 3 crazy results. The first being that infinity plus 1 is equal to infinity. Now if this already does not sound crazy to you, consider this. Let's say you have a partner, you're married to someone, and then you go out and get an additional partner. Now you can't really do that because that would be wrong. You would be cheating on your present partner. But suppose you were living in an infinite dimensional reality, which is mathematically possible. And over there, you went out and got an additional partner. Over here, you wouldn't be doing anything wrong, because in this video, we've shown that infinity plus 1 equals infinity. And in fact, you could go out and get an infinite number of partners, and you still wouldn't be doing anything wrong. Because in this video, we also showed that infinity plus infinity equals infinity. In fact, you could go out and get an infinite number of partners for every partner you already have, and you still wouldn't be doing anything wrong, because in this video we showed that infinity times infinity is equal to infinity. Pretty crazy. Now you might come and ask me, Arman, how does this information help me in any way? This doesn't affect my reality because I don't live in an infinite dimensional reality. To that I would say that our imagination is not bound by reality. Our imagination is infinite. So if we cannot be free in our reality, we can be free in our imagination.